Just please. Thank you. Right. So this one should finish off the rest of the videos. So right. So let's start off then. We're going to start with this. Now this is pretty tricky. So multiple arguments are a lie in Haskell. Now what the hell does that mean? Well, if I've got add three numbers here, A, B, C, you can see I've got three arguments and it outputs the addition of those three. But it actually only takes one argument at a time. So it's taking in one argument here and then applying it to another function, that argument to another function. Right, so what does that look like? Now this next one I think explains it pretty well. So there's our initial function, add three numbers A, B, C. Now what it actually is doing, if we call it with 1, 2, 3, 1, 2, 3, we create a new function, we partially apply a function where 1 is added to B, C. Then we apply another function called add numbers 3, 1, 2, where we add 1 and 2 to our one argument C, and that's what we want to end up as. So what we have then is add three numbers 1, 2, 3, which we know is going to give us 6. If we add 2 and 3 to 1, that gives us 6, and then we add 3 to 1 and 2, that will also give us 6. So that's kind of what's going on in the background. Now, so partial application of functions is slightly different, but it's all the same thing. So let's have a look at this. So I've got a function called sub xy. So let's put that in. So I've got one called sub xy, and that's equal to x minus y. Okay, let's just run that. Right. So if I call sub, 10, 5, 2, 3. So it's 2 from 5 gives us 3. Now I'm going to create another function here called sub 6. Now that's going to equal sub 6. Right, let's run that. Now, let's just run that. So I'm going to call sub 6. And then I'm going to call it 10. Now, what on earth has happened there then? Well, I've created a function called sub 6. It doesn't seem to have any arguments. I haven't specified one, but it has 1. That 1 is assumed because sub 6, I've only called sub here. I'm trying not to get these two mixed up. Sub here with one argument, so it's missing argument. So the missing argument comes from here. Okay, even though I didn't have to actually say what it was. So I call sub with 6. Now it should be fairly obvious where the 6 goes. Is the 6 the x or the y? Well, it must be the x because we've got a negative value there. So the missing 10, this missing argument comes from when I called it down here, the x. That goes into the y. So it's 6 minus 10 to give me minus 4. All right. Now I can do, let's say we want to write a function called dec. Okay, so that just decrements a value by minus 1. All right, so I could call sub here 1. Okay, now let's just try that. Now it's not going to quite work as expected, but let's try it. So dec 10 minus 9. Now notice that didn't really kind of work, so let's just do I have to create a new function here where I'm doing it the sub the other way around. So I'm going to call sub, oh this is not good names, but subdec, and then x, y, but now I'm going to have to go y minus x, alright, and I'm going to call subdec here. So let's run that, and then if I call dec 10 this time, 9. All right, so you can see the 10 has gone into y there. 1 is x, but then we flip them around here, so it's 10 minus 1. Okay, easy. Well, I say it's easy. It's something to think about. Right. Okay. Now, there's our partial application of functions. There's some questions to do. Pretty easy, straightforward. Right. Now we look at higher order functions. Now, higher order functions are functions that take other functions as an argument or return another function. All right. So that's been a question I think before. They all perform actions on lists. So the first one is map. So map, a function that we apply to a list, and then it outputs a list. All right. Now, when we have a list, we can just specify our list here. So I can just say nums equals 1, 2, 3, 4, like that. And then I can do my, I need to run this to say that. So I can say map. Now let's go for the example I've got here is double. Now double function doesn't exist, so let's create it. So double x equals x times 2. So whatever I'm putting in there. So I'm going to say map. No, I need to run it. Sorry. Now it doesn't need to be in brackets, so it's map. Then in brackets double. There's our function. And there's our list is nums. And I've cocked up the brackets, which is fair enough. Right, there we go. So you can see that it's doubled it, but nums is still the same. All right, still 1, 2, 3, 4, but it just returned another list there, but didn't actually change the existing one. Now you can also do, when you have a list, you can go, okay, I can just do, whoops, like that, and then that simply means a list from 1 to 100. That's quite nice. It's quite easy to do. So there's map. So map applies a function to every element in a list, returning a new list. Okay. Now the one after that is filter. So this applies a condition to every item in a list. So if I did, it's pretty straightforward now, if I did, so we said filter, and then I'm going to say greater than 2 to my nums list. It's just 3 and 4. Yeah, easy as that. Okay. And then we have fold. Now fold is slightly different in the fact that it returns a number on rather than a list, whereas filter and map return a new list. This returns a value. So in this example here is adding 0 to the first element in the list, and the answer for that is then added to the next element and so forth. So if I want to add up all the elements in my list, I can just do fold, left or right, makes no difference. So the function is plus, I want to add 0 to start with, and then it's nums, and it's 10. So all of those added up. Now I had to add 0 because it would have added 1 to 1. So if I made that 1 there, it would be 1 out. Okay, so that's why it is 10. All right. So fold, because I'm doing fold left, it's starting on the left and going that way. If I did fold right, it could work the other way around. Okay. So there's our 3 higher order functions. So again, they're functions that take in either a function as an argument or return a function. Okay, and you can see in this case we're using a function as an argument. Okay, there's some questions there, and that's where you can put your answers. Now the last bit now is on lists, which is quite straightforward. So let's get some lists of these things here. So let's have names, because they're straightforward. So let's add names here. Right. Now, the two main functions I can do to my list are head and tail. So I can say head, that's head, names. That returns the first element in the list. Now, if I did, that doesn't really work, does it? Tail, names, that returns everything apart from the first element in the list. Now, what you can do is you can nest these. So I can say head, tail, and I can keep going with that. I'm going to names. That returns Bob. So there's the tail of names, and the head of that is Bob. Okay, easy. And if you look on your notes here, you've got, there you go, a lovely diagram there. Right. Just do a quick one on that one there. So if you want to add something to my list, now be careful what I'm saying there. So if I said names plus plus Ronnie, whoa, no, internet, don't go. Please, no. Don't do this. I'm hoping it's okay. Okay, let's quickly try and save this. Okay, that one's connected. It's back, I think. Let's just run it. Okay, you can see Ronnie's there looking like he's been added to names, but he hasn't. If I just did names, it's all to do with the immutable. There we go. So you can see names doesn't actually have Ronnie, but it created a new list with Ronnie in it. Okay, now the very last bit now, I think. Okay, recursively processing a list. Now let's get the code for that. And okay, let's get that in there. Now, so what's this then? So I've got this thing called mult list by 4. So it takes in a list and it outputs a list. All right, seems like something that we've done fairly recently. Map, in other words. So what does this mean, this notation here? Well, X and XS. Now, I could have called that anything you like, but you'll also always see in the online and books, it's written like that. So that's the head of the list, that's the tail of the list, XS. So it's calling this times by 4 function here with the head of the list, so it multiplies it by 4. And then it's then calling mult list by 4 with the tail of the list. So that comes back in times the head of that tail by 4, puts it back in the list. So let's run that and see that working now. So now it's case sensitive, so make sure you get that right. So I'm going to copy that. So mult list by 4. So I need to create a list. 1, 2, 3, 4. I could have just used nums, couldn't I? No, done that. Okay, you can see that that's worked there. Now I could have just done map. Yeah, I could have said map, that's my function, times by 4. But this is on the syllabus, so we have to show you this one as well. So map times by 4, and then 1, 2, 3, 4. Which is easier? Map is, obviously, but you can just see how that's more or less what's going on in the background with the map function. Okay. Now you'll see that is the very, very last bit, and the rest is just exercises. So there we go, we're done. It's quite tricky, some of that, but you might need to go over that again, but it's not too bad. Okay, any questions then in class?